Okay, so in this section, we will discuss about how to describe and explore the data and finally compare the data. Okay, so we start with the measures of center. So in this section, we're going to explore how to measure center of the data. Center means think about this. You would like to find out average household income in a city, then that means that average stands for center of the data, and there are different ways to measure that center. Okay, so our goal is to talk about how to measure the center, especially we use mean and median to represent center. Okay, so start with the mean. A measure of center is a value at the center or middle of the data set. So that value could be mean, could be median, could be mode, could be mid range. Okay, so let's start with the mean. The mean, which means actually arithmetic mean of a set of data, is the measure of center found by adding all of the data values and dividing the total by the number of data values. So this is how we find the mean. If you have given a data, add all of them and divide that sum by a total number of data. Okay, so we often use average for mean, but that's not the word we prefer to use because the average term is not used by the statistician. So this average doesn't always mean mean. It could be something else like median, or could be mode, or could be mid range. So you have to be mindful that average always does not stand for mean for us. Okay, so if we important properties of the mean, sample means drawn from the sample population tend to vary less than other measures of center. Remember, there are other measures of center like median or mode or mid range, but if you take sample mean from the sample population, then the mean varies very less. But one of the disadvantages of the mean is sometimes the outlier value could be can change the mean in a huge manner. For example, let's say there are 5 family with and our goal is to find out the average household income. Okay, and this is a sample we are taking, and let's say for the first family the household income is 20k, 30k, 40k, 50k. And now for this 4 family, the same the average would be addition of this number divided by 4, which is almost 35k. But let's say there is a family which makes 500k. So this number is an outlier. Now if you try to find out the mean of this 5 family, then you have to add all this number and divide by 5, which is if you add 550, 590, 620, 640k divided by 5, which is 128, 128k. That's the mean of this household income for this 5 family, but that does not represent actually the average value. So in this case, because of this outlier, because of this huge number, the mean is not measure of center. Okay, there is a one word called resistant. A statistic is resistant if the presence of extreme value does not cause it to change very much. So here the presence of this outlier cause change very much. That means mean, using the following definition, we say that mean is not resistant because of this outlier. Mean is not resistant. Resistant means it's that outlier should not affect that much in that measure of center. Remember, one more time, measure of center means a number which we are planning to use to represent a center of the data. Okay, so this is how we use formula for finding the mean. We try to add all the data and divide by total number of data. This is the notation we use. This notation is also called sigma, which means sum of all the data. This X is the data. So if the data are sampled from a population, the mean is denoted by X bar. This X bar means it's a mean but for the sample. And there is a different notation called mu. This is also mean, but that's for population. So sigma, this is the first one, notation is sigma, that represents the sum of the data. That is the notation for the sum. X means the data value variable. N is the number of data value in sample, and capital N is the number of data value in population. So if we are playing with the sample, this is the formula we're going to use for finding the mean. And if we have given population, then this is the formula we're going to use for finding the mean. Both of them represents mean, but one is with the sample and one is for entire population. One example, data set. So let's say there is a data set. Don't worry about this number. These are the data sets you have given. 1 2 3 4 5 6 7 8 9 10 11 datas. So data set, instead of 33, think about data set given here. Disney World wait times includes wait time in minutes for 6 popular rides. So these are the time for the 6 popular rides. Find the mean of the first 11 wait times for Space Mountain at 10 a.m. So for finding the mean, you just have to add these numbers and divide by total number of data. So if you do that, this is the number we're going to get, which is 39.1 minute. Okay, the mean of the wait time for Space Mountain is 39.1 minutes. So that's the mean. There is another measure of center that's called median. Median means it's the middle value of the data, and depending on either you have odd number of data or even number of data, there is a way to find the middle number. And the good thing about this median is it's a resistant measure of center, meaning the outlier or any outliers would not affect that much for the median, like it did for mean here. This outlier, because of this 500k, the mean is very, very high. Mean is not resistant, though median is resistant. Okay, so for finding the median, we try to sort the data either in increasing or decreasing order and find out the middle value. Now, depending on how many data you have, if you have odd number of data, you can always exactly find the middle number. If the number of data value is odd, the median is the number located in the exact middle of the sorted list. So you have to sort the data first and then find out the exact middle number. If there are even number of data, the median is found by computing the mean of the 2 middle numbers in the sorted list. So for example, let's say this is the same example. First of all, for finding the middle, we need to count how many datas are there. There are 11s, and then after that we have to sort it. So here in this case, we are sorting it from lower to higher, and because there are 11 number of data, the middle number is 35. 11, 5 to the left, 5 to the right. So this is the middle number. Because the number of data value is an odd number, the median is the data value that is exactly middle of the sorted list, which is 35 minutes. Remember, 35 is the median for this data, whereas 39.1 was the mean for the data. So they are different values. Okay. So repeat of the previous example after including the 12th wait time. So now we're adding one more wait time. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 11, now there are 12. So we have to first sort the data And because there are two middle number 1, 2, 3, 4, 5, 6 and 7, these are the two middle number. Because to the left of these two number there are 5 datas, to the right of these two number there are 1, 2, 3, 4, 5 datas. So for finding the median of this type of even data set, you have to add these two middle number and divide it by 2. Okay, there is another center of measure that's called mode. Mode means it's the highest greatest repeated value. The mode of the data set is the value that occurs with the greatest frequency. The mode can be found with qualitative data. A data set can have no mode or one mode or multiple modes. So these are the observation. If you have two mode, that means that's called bimodal. If you have more than two modes, that's called multimodal. If you do not have any mode, that's called no mode. I'm going to give you example here. This is the data set. We sorted the data, and after sorting we can see that 30 repeated 2 times, 35 is repeating 3 times, 50 repeating 2 times. So that means 35 is has the highest repeated value. So that means 35 minute is the mode because it's 3 times. For the 2 mode, let's say these are the data we are playing with. 30 and 50, they are repeating same number of times. So that means there are 2 modes, 30 and 50. No mode, let's say this is another data set. So here nothing is repeating, so that means we don't have anything, no mode in this case. There is another the measure of center that's called mid-range. For finding the mid-range, we have to sort the data and we have to find this value, add maximum data value plus minimum data value and divide it by 2. That gives you mid-range. Okay, the mid-range is not resistant. It changes because of the outlier, so it's not resistant. Though it's the properties of mid-range, it's very easy to compute. So because of the mid-range, we can say that there are different ways to measure the center. So sometime we use mid-range incorrectly for the median, but that's not the case. They are totally different value. So let's say this is the data and we would like to find out the mid-range. First of all, we need to sort the data, and after sorting the data we can find the maximum value, which is 75, and minimum value, which is 20. Add them and divide it by 2. That gives us mid-range. While calculating this measure of center, you might have to sometime round off, and these are the rules we can use for rounding. For the mean, median and mid-range, carry one more decimal place than in the original set of data. So one more decimal place than original set of the data. If your data value doesn't have any decimal number, then after calculating mean, median and mid-range, go up to 1 decimal place if your calculation have more than 1 decimal. For the mode, you don't have to do anything. Mode means maximum repetition, so you don't have to round it. Use exact number. Okay, so we can always calculate measure of center from a sample numbers, but we should always think about whether it makes sense to do that. Sometime we can calculate the number, we can measure the center, but sometimes it doesn't make sense to us. So I'm going to go over some examples where this measure of center doesn't make sense. Okay, so always we have to think about either that makes sense or not, and we also have to think about how we are using samples, our sampling method. So one example, let's say you have the zip codes. This is the data for the zip codes. Zip codes of the Gateway Arc in St. Louis, White House, Air Force Division of the Pentagon, Empire State Building, and Statue of Liberty. So these are the zip codes for 5 different location. But even though you can find the measure of center, you can measure the center, but it doesn't make sense because this is just these are just zip codes. The zip codes doesn't measure or count anything. The number are just labels for geographical location. Another example, let's say there is a ranking system of different university in this case, in our example, medical school of Harvard, John Hopkins, Newark University, Stanford University, and Duke University. And these are the ranking. In this case, in this ranking, finding the measure of center, it doesn't make sense because you cannot use that information. The ranks reflects an ordering, but they do not measure or count anything. More example, these are the jersey number, and it doesn't make sense to find the measure of center. And these are the compensation for top 5 annual compensation. So it's for the top earner, so it's not actually measure of center. Okay, and here is another example. The 50 mean ages computed from the means in each of the 50 states. If you calculate the mean of those 50 states, 50 values, the result is not the mean age of the people in the entire United States. So first of all, we take the mean of each of the states, and now we're taking the mean of the mean, which is not going to reflect the mean of entire United States. So it doesn't make sense to calculate the measure the center here. Okay, sometime we also have to calculate from the frequency distribution. If you remember from previous sections, we have the frequency distribution. To calculate the mean from frequency distribution, we can use this formula. We can always multiply the frequency by midpoint of the data set we have given and divide by the total frequency. I'm going to give you one example here. This is the class interval, and this is the frequency. This is the mid value of this interval, like 0 to 14 mid value is 7, 15 to 29 mid value is 22, 30 to 44 mid value is 37. To calculate the average, first of all, multiply these two, that gives you frequency times mid value. Add this column here and divide this by total frequency. That gives us mean from a frequency distribution. Sometimes we have frequency distribution and we can also calculate the mean. Sometimes we have to calculate the weighted mean. So for calculating the weighted means, we have to multiply the data with its weight and divide it by the total weight. This can be useful for grade point average. For example, let's say A stands for 4, B means 3, C means 2, D means 1, F means 0. Let's say these are the corresponding weights for these grades. Then we need to calculate the grade points, compute the grade point average. So this is the example. For a student, C got A, B, C and F. So 2 A's, 1 B, 1 C and 1 F. We want to find out the grade point average, GPA. And for that, we have to multiply the grade with its corresponding weight, and then divide it by the total number of weights. That gives us 3.07 as a GPA. So in this case, we did not round it. The result is a first semester grade point average, which is 3.07. But instead of rounding it to the 1 decimal place, we just leave it to the 2 decimal place because of our common practice. Okay, so these are measures of centers. I'm going to show you some examples from the homework problem I have assigned for you. So let's start with the first one. A defunct website listed the average annual income for Frida as $35,031. What is the role of the term average in statistics? Should another term be used in place of average? So let's look at the choices we have given. The term average is often used in statistics to represent the median. That is not true. Average means it's a mean, median, mode, mid-range, everything. The term average is not used in statistics. The term median should be used for the result obtained by adding all of. Median doesn't mean this thing, so this is not right. The term average is often used in statistics to represent the mean. That is also not right. First three are not right, so answer should be D, but let's read it. The term average is not used in statistics. That's right. The term mean should be used for the result obtained by adding all the sample values and dividing by the total number of sample values. That is the right choice. Okay, let me choose another one. Let's say number 5. Find the mean, median, mode and mid-range for the data and then answer the given question. So these are the measures of centers and data is given here. If you click here, it will give you give you the option to copy this data in Excel, StatCrunch or Clipboard. That's up to your situation and if you like to use one of them, then you can always use them. I'm going to use Excel, and when I click this, I do have this data. The good thing about the Excel is I can sort this data, I can sum it, I can divide it, I can do the calculation. So I'm going to just highlight this data and go to the data, under data here, sorting, and sort smallest to the largest. Now it's already sorted, as you can see here. So first case, find the mean. Mean it's a sum of these data. So I'm going to add from here up to here to here. So from A1 through A11 I'm adding them. That can be done by using sum command. And now I'm going to divide this sum by total number of data, which is 11 in this case. So this is my mean, which is 9.618182, but according to the instruction, type an integer or decimal rounded to the 2 decimal place. So 2 decimal place would be 9.62. So it's a 9.62 inches. Nice work. So look at here. Listed below are foot length. So this data represents the foot lengths in inches of randomly selected women in a study of a country's military in 1988. So are the statistics represents of the current population of all women in that country's military. So that is what we are looking for. So we found the mean. Now we're going to find the median. Median means it's the middle number. So as you can see here, there are 11 data. So middle number would be 9.6, the sixth one. So it's a 9.6. Okay, now for the mode, look at here if anything is repeated. 9.9 and 9.9, it's repeated 2 times, 10.4 repeated 3 times. So the mode is the highest repeating number, which is 10.4 in this case, 10.4. Finally, mid-range. Remember the mid-range, the formula is you add the least number to the highest number and divide it by 2. So that's 9.5. So I took the smallest number and then the highest number, I add them and divide it by 2. Finally, are the statistics represents of a current population of all women. So look at here, these are the data from 1988 and we are trying to answer for the current population. So the answer should be no, because it's a time difference, it's a huge time difference. So let's look at the choices we have given here. Since the sample is random and the sample size is greater than 10, the sample can be considered to be representative of the population. Since the sample is not random, it's not true. This is true, but we cannot use it because it's not current. Since the measurements were made in 1988, they are not necessarily representative of the current population of all women in the country's military. That looks right. So remember, though we can find all the measures of center, it doesn't mean that practically we should be able to use them. Okay, so let's go to next problem. Let's say problem 10. We have given data for body temperature. If you click here, you will be able to find the data. So for this 1 2 3 4 1 2 3 4 5 6 7 8 9 10 11 12 12 times 4 is 48 data. Do not try to use this huge data manually. You always have to use the technology for finding the the information we are looking for. We are looking for the mean, so we can copy this in Excel the way we did last time here. So I copy it. Now I'm going to sort it. So the data sorting column A, smallest to the largest. So now it's sorted. So there are 48 data. For finding the mean, it's sum of the data divided by total number of data. So I'm going to use a very same approach the way we did before. Find the mean. Mean is sum of the data, sum from column A1 to A48, that is the data we're adding, and we are dividing this sum by 48 because there are 48 number of data. So this is the mean, which is 97.95. If you want to round it to the 2 decimal place, it's a 97.95. That's right. Median is the middle value. So as you can see, the total number of data, it's even number 48. So the middle, there are two middle value, 24th and 25th position, but both of them are same. So when you try to take average of these two, it would be 98. So the next question is, do the results support or contradict the common belief that the mean body temperature is 98.6? Look at here, both of these data are less than 98.6. So it's not, these data are not supporting the common belief. So our answer is the results are inconclusive because the median body temperature is not equal to 98.6. That's not the correct choice. The results are inconclusive because the mean, that is also not correct. The results contradict the belief that the mean body temperature is 98.6 because both the mean and the median are less than 98.6. This looks right. Let's say one more. Which of the following is always true? Choose the correct answer below. For skewed data, the mode is rather farther out in the longer tail than the median. Data skewed to the right have a longer left tail than right tail. In a symmetric and bell-shaped distribution, the mean, median, and mode are the same. This is always right. If you have bell-shaped distribution, normal distribution, in that case, always we have mean, median, and mode are same. A distribution of the data is symmetric if the left half of its histogram is roughly a mirror image of the right half of its histogram. That's only possible if we have mean, median, and mode same number. Okay.